Okay, people, we're on here. Guys, these are one of them's challenge problem. This is an inelastic collision, right? Because it says bounces backwards. What was the equation for, I'm sorry, elastic, my bad. What did I say? Inelastic. Elastic, it bounces backwards. Chase, I'll give you a shout out. What is the equation for the elastic collision? Elastic. Yep. M1V1 initial plus M2V2. Uh-huh. M1V1 final plus M2V2 final. Okay. All right. Let's enter in our information. Here we go, Christian Lasher. 2.5 kilograms steel balls at rest. If it's at rest, what's the velocity? 0. Okay. After the collision, the bullet bounces backwards at 5 meters per second. How fast was the ball moving when the bullet bounces backward? Let's draw the problem. And it says in the previous problem. So in the previous problem, I'm guessing the mass is 35 grams and it's moving initially. It's 0.035 kilograms. And it's moving at an initial velocity of 475 meters per second. Okay. But this time it encounters a steel ball. So let's draw this, Logan. Okay. We got the bullet. We got the steel ball. Okay. That's before. And then after the bullet bounces backwards, putting backwards. Well, which way is the steel ball going to go? Okay. It's going to go backwards or it's going to go, obviously, it's going to go this way. Okay. So that was at rest. So then after, the mass never changes, right? And how fast was the ball moving when the bullet bounces backwards? Well, yeah, kilogram steel ball at rest. And we don't want to know the final velocity of, after the collision, the bullet bounces backwards at 5 meters per second. Gosh, this writing's sloppy. 5 meters per second. Okay, the mass of the ball doesn't change. The mass of the ball is 2.5 kilograms. It would, Greenie. That's a great, if a piece got chipped off of it, it would. So this is an indestructible steel ball. Okay? All right, so we are solving for the final velocity. Okay? 0.035 kilograms times 475 meters per second equals. Now, hold on a second here, people. What did I forget? I forgot that this was a -5. Didn't I, Ryan? I forgot it was a -5. Because if this were the positive direction, this would be the negative direction. Well, that changes the math, doesn't it? All right. So that's 0.035 kilograms times -5 meters per second plus 2.5 kilograms VF. Now, do you guys want me to show you a shortcut real quick? Check this out. Can we get rid of this and this? We can. Okay, we can get rid of the 0.035. Why not? Okay. So I can do that. I can do this. Math class. If you want me to do this way, 475 meters per second plus 5 meters per second divided by 2.5 kilograms. Because that factors out. The kilograms factor out, right? You see that? No, Miss Rapp doesn't like that at all. Okay, so this would be a negative number, right? And I would have to add it to this side. But you notice that the 0.035 is used here and there. I can just pull that out. I can just factor it out. That's right here. And then I'm left with 475 plus 5 because I had to move it to the other side. Guys, multiply and then divide. What do you get? Miss? What? 6.72. Okay, so you end up with a positive 6.72 meters per second, which means the steel ball is moving this way, 6.72 meters per second. It's moving that way in the positive direction. Did you get that there, Alejandro? Sleep a little bit? You know what always helps me? Looking at the trees, man. Go look at the trees. Now, these positive and negative numbers are very important in the next challenge problem. Okay, so Logan, we have to pick a positive direction. We have to pick a negative direction. So let's go to the next one. Next challenge problem here. A 0.5 kilogram ball traveling at 6 collides head on with a 1 kilogram ball moving in the opposite direction. So now we're going to draw our ball, and we're going to draw our ball. All right, which way do you want to be positive? To the right? Positive to the right. Negative to the left. Yeah? So this one's 0.50 kilograms. This one's traveling at positive 6.0 meters per second. This one's 1.00 kilograms. And this one's traveling at negative 12.0 meters per second. Okay, bigger and faster. Now, what it wants you to do is after the collision, which direction are these things going to be moving? Well, I think you guys know that if this is smaller and lighter, it's probably going to be moving back this way, right? But the question is, where's the final velocity of this ball? Okay. So what is going to be the sign and the number of that ball? So I will leave you guys to that. I'm going to shut off the McDonald's video here, and you guys are going to solve it. No, you guys are going to solve it.